Welcome to Unit 4 Quiz 2 Study Guide. I'll be going through the even problems. Once again, the odd problems are there just as extra practice in case you want to do that with the answers to those odd problems attached at the end of the document. So, and this video is just in case you got stuck as you were trying to work on them as your own. I wouldn't advise just watching the video and writing down what I do. I would definitely advise trying them on your own first, and then using the video just to check your work or to help yourself on things you got stuck on. So without any more being said, I'll go ahead and begin here. So starting off with our first even number there, number 2. We're being asked to take out a common factor, and they want us to take out the greatest common factor. Now, whenever you do that, basically you want to take out two things if possible. You want to take out the biggest coefficient you can. The coefficients are the numbers 8, 12, 12, and 12. And also you want to take out some x's if possible. In this case, there are some x's available. We'll see if we can take any of those out. All right, so here's our first thing we're going to do in doing this problem. We're going to make a set of parentheses, a blank here, and then we're going to make a blank for each result that will come about as taking out the factor. So what's the biggest thing that divides into 8, 12, and 12 and 12? Well, that would be 4. So I'm going to divide 4 out of all of these. 8 divided by 4 is 2. 12 divided by 4 is 3. 12 divided by 4 is 3, and so on. Now the next thing you want to do is you want to take out some x's if possible. This one has 6 x's to give. This one has 3 x's to give. This one only has 1, and this one actually doesn't have any x's to give. Now, since this guy doesn't have any x's to give, that means we can't take any x's out. So they're all going to stay the same. So this is going to be x to the 6th, x to the 3rd, x, and that's it. Now, let's just say you could take out x's. Well, let's say you could take out 2 x's. Well, what you do is you subtract. So you would subtract 2 from each of them. But in this case, we can't, so this is going to be good enough. And that's how you take out a common factor. That's factoring method number 1 that we talked about. Let's take a look at number 4. This one here is a trinomial, a quadratic trinomial. And with those, we use the box method to factor them. You put the first number in the top left, you put the last number in the bottom right, and then you look for 2 numbers that multiply together to make that top left number. There's only one way to get n squared, and that would be n times n. Now 20, we have a couple of options, but we want to figure out what times what makes 20. It could be 2 times 10, or it could be 4 and 5. Now I'm going to put 4 and 5, and then you fill in your box. So 4 times n is 4n, and then 5 times n is 5n. And now is the moment of truth. We can see if we picked a good set of numbers. If these add up to make the middle number, then we did a good job. But unfortunately, 5 and 4 does not make 12. And so we need to back up and try again. Now, the first thing you do whenever you don't have a good pick is you could sometimes just try switching the numbers. Now, I'm not going to do that. I'll write it, but I'm not going to actually do it because I already know that's not going to work either. But that is typically the first thing you want to try. But if just switching those numbers around doesn't work, try a completely different set of numbers. So what else makes 20? How about 10 and 2? And there it is. 10 plus 2 does make 12, so we have our answer. N plus 2 and n plus 10. And there you have it. Got a couple of those that we'll look at, and I gradually pick ones that are a little bit more challenging every time. So let's go ahead and take a look at number 6. Same process, just maybe a little bit more challenging. All right, what times what makes 5a squared? Well, one of them has to be 5a and the other one has to be a. There's pretty much only one option for that. But what makes 40? Well, there's actually quite a few options that make 40. It could be 10 times 4, or it could be, 10 times 4, or it could be 8 times 5. What else? It could be 20 times 2. There's a lot of possibilities. Let me list them over here. 2 and 20, 5 and 8, and 4 and 10. Okay. Now, usually it's going to be the less extreme numbers. Like this is extreme because there's one really low number and one really big number. So I usually like to pick the middle numbers first. So like 5 and 8 are more moderate. So I'm going to go with those. And let's see if that works. 5 and 8. 5 times 5 is 25a. 8 times a is 8a. Do these add up to make negative 54? No, they don't. So that's not going to work. We could try switching those, and we could put the 8 up here and the 5 here. So 5 times 8 is 40, and 5 times a is 5a. Does that work? Nope. Once again, that doesn't work either. We don't get negative 54 that way. So that means 5 and 8 just don't work. So we need to try something else. Let's go with the next more moderate pair of numbers, 4 and 10. 5 times 4 is 20, and 10 times a is 10a. Let's see if that works. All right, so 10 and 20 makes 30. That's not what we want. Let's try swapping them around again. I'm going to put the 10 up here this time and the 4 here. So that's going to be 50a, and that's going to be 4a. And now we do get 54. It's not the right sign, though. That's a positive 54. We want negative, but that's an easy fix. All you have to do is change the signs on both of the numbers, and you've got it. So there we have it. We have 5a minus 4 times a minus 10. All right. Go ahead and take a look at the next one. Number 8. One more like that. And I just like to include a lot of examples of these because sometimes these can be kind of tedious. So what makes 9k? Well, we have two options there. It could be 3k and 3k, or it could be 9k and 1k. It's kind of difficult to tell. So I'm going to go ahead and start off with 3k and 3k, and we'll see if that works. What makes 24? Well, there's a lot of things that make 24. There's 2 and 12. There is 3 and 8. There's 4 and 6. Technically 1 and 24, but that's really extreme, so I doubt it's going to be that one. So I'm going to start with the more moderate pair of numbers there. Let's try 4 and 6. Complete the box. Does 18 and 12 make 58? Unfortunately, no, it does not. And switching the numbers around this time isn't going to matter because the 3's are the same here. So if you switch the 4 and the 6, you're going to get the same result again. So there's no point in that. So that means that 4 and 6 just doesn't work. Let's try 3 and 8. See if that makes any difference. Does 24 plus 9 make 58? Nope, no bueno. But good news is I don't have to worry about switching them around because once again, the 3's are the same, so switching it won't matter. Let's try the 2 and the 12. That's going to be 36k here and 6k here. And that's still not going to be enough to give me 58. Well, let's try one more pair. Let's see if we get lucky here. 2 and 12 aren't it. So all I got is 1 and 24. 3k times 1 is 3k. 24 times 3 is a really big number. I think that's 72 if I'm not mistaken. And nope, 72 and 3 cannot make 58 either. So none of these options are working. You know why that is? That's because it must not be 3k and 3k. There must be another way to get 9, and there is. So how about instead of the 3k's, we try the 9k times 1k. And now let's give it a try again. So I'm just going to start over. I'm going to start with the 4 and the 6. Let's keep our fingers crossed because, like you, I'm getting a little sick of this now. Ah, got lucky. Cool, it works. 54 and 4 makes 58, and there it is. So we have k plus 6 and 9k plus 4. And there you guys have it. All right, so you just got to keep trying combinations until you get one that works. All right, this is a different factoring method. You'll be glad to have this after those last 3. Much faster and easier. This is the difference of squares method. Anytime you have 2 perfect squares being subtracted, all you have to do is break these numbers up evenly. So for instance, what times itself makes 9x squared? Well, that would be 3x and 3x. What times itself makes 25? That would be 5 and 5. You make one a plus, you make one a minus, and you're all done. Much nicer than the box method. Let's go ahead and take a look at another problem. All right, so for this problem here, it's got 4 numbers in it. And for that, we're going to use the box method again. But this box method's a little bit friendlier than the other one. The one that has only 3 numbers is pretty tricky. This one has 4 numbers, and there's a little bit less guesswork going on here. So the first number goes here in the top left. The last number goes here in the bottom right. The other 2 numbers go in the other spaces, and it doesn't really matter where you put them. Now, in this one, we don't have to guess numbers. We can figure them out. So to figure out what goes here, I just need to look at what is the greatest common factor for these 2 numbers below it. So what is the biggest thing that divides into both 18 and 42? Well, the biggest thing that goes into 18 is 9, but 9 does not divide into 42. So what's the next biggest thing? How about 6? 6 goes into 18, and 6 goes into 42. So it looks like we could take a 6 out. And what about the p's? I've got 3 p's here and 1 p here. Looks like I could take 1 p out there. So I'll put a 6p there. To find this number, we do the same thing, but with just these 2 numbers below it. So notice how both of these are negative. When that happens, we know it's going to be negative. 3 and 7 don't have anything in common, so that means the greatest common factor would simply be a 1. And notice how there's also no letters to take out because 7 doesn't have any letters to give. Now we do the same thing but going horizontally. So if I want to find this number, I'm going to find the greatest common factor for these 2 numbers. The biggest thing that goes into 18 and 3 is 3. And this one has 3 p's, this one has 2, so I could take out 2 p's there. And then the biggest thing I can take out of 42 and 7 is 7. And this one doesn't have any p's to give, so we don't have to worry about the p's. So we're done. It's always good to go back and double check, make sure that these things do multiply together to make the inside. But once you've double checked that, you have your answer. And that's the box method for when you have 4 terms. All right, so for the last bit here, these are going to be the general factoring strategies. In other words, you're going to have to factor more than once. So you always start by taking out a GCF. After that, if there's 2 terms, then you're going to do the difference of squares. Maybe. If you can. Okay, so if you can't do the difference of squares, then don't. But if you have 3 terms or 4 terms, then we're going to go with the box method. Okay, and that's pretty much it. And you just kind of keep factoring these until you can't factor anymore. All right, so let's go ahead and get started here on this last set. So we always start by looking for a GCF. Is there anything we can take out? Well, 36 and 4 can both be divided by 4. So if I take out a 4, I'm going to have 9p to the 4th power minus 1. And that's all I can take out there. There's no p's that I can take out. Next, I'm going to look at this. Is that a difference of squares? It turns out that it is, because I can break that apart evenly into 3b squared and 3b squared. And I could break that apart evenly into 1 and 1. We'll make 1 a plus and 1 a minus. And we're done, because first of all, the GCF is done for. Second of all, this is not a difference of squares, it's a sum of squares. And third of all, this is not a difference of squares because 3 is not a perfect square, so we're done with that. So that's as far as we can go with factoring this. Let's take a look at another one. Once again, we start by taking out our GCF, and I think there is one. 22 and 48, all of 3 of those can be divided by 2. So that's going to leave me with 10n squared minus 1n minus 24. Notice I can't take out any letters because the 48 does not have an n on it. Now this has 3 terms, so to factor that, we would use the box method. After I use the box method, I'll have probably my answer. So let's see. 10n squared goes here, negative 24 goes here. All right, so let's go ahead and find out what makes 10n squared. I'll start off by trying 5n and 2n, and if all combinations don't work for that, we'll have to try again with 1n and 2n. And let's go ahead and try in 3 and 8 for the 24. Now, one of them has to be negative. I like to do the negative at the end, though, to make sure I know which one's supposed to be negative. So 5n times 3 is 15n, and 8 times 2 is 16. Now 15 and 16 can make negative 1 if we subtract the 16, which means that the 8 would be the negative one. So we have 5n minus 8, and 2n minus 3. All right. Number 18. Once again, we want to take out a GCF. What goes into 48, 40, 60, and 50? Wow, pretty big numbers there. Let's see, I know that 50 can be divided by 10 or 5, but that doesn't work for any of these. I think maybe the biggest thing I can take out is a 2. Let's try that and see if there's anything. Yeah, I think that's all that's going to be left. So if you divide each of these by 2, you get 24, 20, 30, and 25. 25 can only be divided by 5, and 24 can't be. So that's the best we could do, is taking out a 2. Also, this one has 3 x's, this one has 2 x's, has 1, but this one has no x's, so therefore we can't take any x's out, and therefore the x's will be staying the same. And now we're going to do the box method on this guy, because it's got 4 terms. First term goes here. Last term goes here. The other terms go in the other remaining spots. And then we just factor out what each row and column has in common to find the greatest common factor. So for those two, I think the biggest thing that goes into both of those would be 4x squared. For these two, 5. For these two, thinking probably 6x. And then for these two, thinking maybe 5 again. And so we have 2, 4x squared plus 5, and 6x plus 5. And none of these can be factored anymore, so we are officially done with that one. All right, and that does it for our study guide there, so hopefully that was helpful. We'll see you guys in class.